All right, let's talk about foam firefighting systems. Today, we are going to build one from the ground up. And this is a practical guide for every single person on the job site. I'm talking from the engineer with the blueprints to the crew that's actually installing the pipes. We're going to cover the whole shebang, from the first calculation to the final handshake. And we're going to focus on what really matters to make sure these systems work when lives are on the line. So here's our game plan for today. We're going to start with the basics, the magic of how foam actually puts out a fire. Then we'll hit the drawing board and talk about designing a system that's built for success. After that, we'll meet the key players, the hardware, and then get into the nitty-gritty of putting it all together on site. And of course, we have to prove it works with some serious testing. We'll wrap it all up by talking about the final handover and the risks you absolutely, positively cannot ignore. Okay, let's dive right in. How do these things actually work? Before we even touch a pipe or a valve, you've got to understand the core principle. Because trust me, once you get the why, every other part of this process just makes so much more sense. So, here's the fundamental problem we're trying to solve. What do you do when you have a fire where water is not just useless, but could actually make things a whole lot worse? I'm talking about flammable liquid fires, things like diesel, gasoline, what the pros call Class B fires. If you spray water on that, you could just spread the burning fuel everywhere and create a total disaster. You need something different. You need a better weapon. And that weapon is the foam blanket. It's a really brilliant solution when you think about it. It's this thick, stable layer of bubbles that just floats right on top of the burning liquid. And it's a triple whammy. First, it cools the fuel down. Second, it creates a physical barrier, literally cutting off the oxygen supply. And third, it traps the flammable vapors so they can't escape and feed the fire. It doesn't just fight the fire, it literally suffocates it. So how do we make this blanket, on demand? Well, it's basically a four-step process that happens in just a few seconds. First, you get a massive flow of high-pressure water from the fire pump. As that water rushes through a special fitting, it creates this intense suction that pulls in a soapy liquid called foam concentrate from a storage tank. Those two liquids instantly mix together to create what we call a foam solution. But the real magic happens right at the very end, at the nozzle, where air gets mixed in, making it expand into that thick, life-saving blanket of foam. Okay, so we know how it works. Now we need to design a system that's going to work perfectly, the first time and every time. And that journey doesn't start with a pipe wrench. It starts with a calculator and a pen. Getting the design right on paper is probably the most crucial step if you want to avoid huge, costly failures down the road. For all you engineers watching, this table is your Bible. This is where every good foam system begins. You have to know exactly what you're protecting, what code you have to follow, and that's almost always NFPA 11, and what type of foam concentrate you're using. You'll get the area from your site drawings, and then the code itself will tell you the application rate you need and the minimum time it has to run. If you mess up even one of these inputs, the whole system could fail. Now, once you have that data, you just plug it into these three basic formulas. And don't worry, this isn't rocket science. The first one tells you the total amount of liquid, the foam solution you're going to need. The second one figures out exactly how much of that liquid needs to be the foam concentrate. And that third one, that tells you how big your foam storage tank needs to be. And see that little 1.2 in there? That's a built-in safety factor. It's really that simple. All of your hard work gets summarized in these three essential documents. You've got your design basis sheet, that's all your math. You've got your material submittal, that's proof your equipment is the right stuff. And you have your inspection and test plan, the ITP, which is basically your quality control roadmap. Now, here is the most important rule of this whole phase. You do not order a single piece of equipment, you do not dig a single trench until the project consultant has put their official stamp of approval on all three of these, period. All right, design's approved. Now for the fun part. Let's meet the hardware. We're going to break down the anatomy of a typical foam system and get to know the three main components that really make everything happen. First up is the bladder tank. On the drawings, you'll see it labeled as BT-01. This is the heart of the system. It's where you keep all your foam concentrate. But what's so clever about this tank is that it doesn't need its own pump. Here's how it works. When the firewater rushes into the tank, it surrounds this flexible bag, or bladder, on the inside and just squeezes it. That pressure is what pushes the foam concentrate out into the piping. It's simple, it's effective, and it's always ready to go. Next is the ratio controller, or RCO1. If the tank is the heart, this thing is the brains of the operation. It's a really smart but simple device. When high-pressure water gets forced through a narrow point inside of it, the water speeds up, and that creates a drop in pressure. It's called the Venturi effect. It's just like when you put your thumb over the end of a garden hose. That low pressure area creates a powerful suction, and that's what pulls in the perfect amount of foam concentrate to get the mix just right. And finally, we've got the deluge valve, DV01. This is the system's main gatekeeper. It's just a huge valve that holds back all that powerful, high-pressure water from the fire pumps. It just sits there, closed, waiting for a signal. That signal could come from an automatic detector or from someone pushing a button. But when it gets that signal, it slams open and whoosh, it unleashes the flood of water that kicks off the entire sequence. Okay, enough talk. Time to get our hands dirty. We're moving from paper and plans to pipes and concrete. This next part is for the installation crew out on site. We're going to walk through the right way to build this system step by step. On any construction site, sequence is everything. If you do things out of order, you're just creating more work for yourself later. So here's the correct flow. Get your permits and paperwork sorted first. Then pour your concrete foundation and get your tank set and level. Then you install your piping, your valves, and all your supports. After that, it's time for the electrical and instrument hookups. Then comes a critical step. You have to flush the entire system with clean water to get all the dirt and debris out. And only after it's been flushed, painted, and labeled do you finally fill it with that expensive foam concentrate. Follow that order every single time. Now, I really want you to pay attention to this slide because it shows one of the most common and, frankly, one of the most dangerous mistakes that happens during installation. This is that ratio controller we just talked about. And at a quick glance, it looks like you could install it either way. But you can't. There's a small arrow stamped right on the body of the device. That arrow must point in the direction the water is flowing, so away from the pump and towards the fire. Check the arrow. Always check the arrow. That 1-second check saves lives. Look, I can't say this enough. If you install this device backward, the suction effect isn't going to work, period. So when there's a real fire, the system will activate, but it's just going to spray useless water instead of foam. The crucial point here is that this simple 1-second check, it is everything. It's literally the difference between putting out a fire and having a catastrophe. So the system is built. It's all bolted together. It looks great. But does it actually work? This is the moment of truth. This is testing and commissioning, where we use real-world data to prove that what we built in the field matches what we designed on paper. First up is the hydro test. What we do is we isolate the system, we fill it completely with water, and then we crank up the pressure to at least 175 psi. Think of it like overinflating a tire just to make sure it's solid. We are looking for any leak, any drip, any weakness at all. That pressure gauge cannot move, not even a little bit. It has to be rock solid for the entire duration of the test. Next, we do what's called a proportioning test. This is where we check to see if that ratio controller is doing its job perfectly. If we have a 3% foam system, we need to take a sample while the system is running and test the concentration. And the rules are strict. The acceptable range is very, very tight. If you have too little foam, it won't put out the fire. Too much, and you're just wasting incredibly expensive concentrate and the foam might not even work correctly. You gotta hit that sweet spot. And all this testing means nothing if you don't document it. This is why the paperwork is just as important as the pipe work. Every single test result needs to go on a formal report. You write down the procedure number, the exact readings you got, and whether it passed or failed. But the most important part of this whole page is right there at the bottom, the signatures. You have to get the consultant, the client, everyone to sign off on it right then and there. This signed paper is your official legal proof that the system is ready for action. And that brings us to our final step, the handover. The physical work may be finished, but your responsibility isn't. Handing over a life safety system like this is a huge deal, and it comes with some serious professional weight. This binder right here, this is your final exam. A complete professional handover package is totally non-negotiable. It has to have the final as-built drawings, all those signed test reports we just talked about, the material certificates for the foam, and the operation and maintenance manuals for the end user. This package isn't just a box to tick. It's your final statement that you did the job right from start to finish. And so I'm going to leave you with this one question. If a fire starts tomorrow, if that alarm bell starts ringing, will this system perform exactly like it was designed to on paper all those months ago? The answer to that question isn't in a textbook. The answer is in the quality of your installation. It's in the direction of that one little arrow, and it's in the integrity of the records you keep. The answer is in the quality of your work.